Morning, everybody. We're going to go ahead and continue where we left off yesterday. We're in section 2.3, and we went through some increasing and decreasing problems before with some graphs. So this is what we did yesterday in this section, just talking about as you go from left to right, if the graph is going uphill, it's increasing. As you go from left to right and it's going downhill, it's decreasing. We have a constant would be a horizontal line. Then we've got this relative max and relative min, or local max and local min we discussed as well. And we did a couple of examples here previously. That talks about increasing, decreasing relative max and relative min. So we did a couple problems on that. And so we're moving on to the next part of this section in 2.3. And this is going to be on even and odd functions. So there's a definition that we have for each of these here. So this is how you know whether it's even or odd. So always the test that you're going to do is you want to find f of negative x. So that just means that you're putting in a negative x for all the x's. So you're doing that first, and then you're simplifying to see what you get. So if you do f of negative x and you get exactly the same function as you started with, we know it's even. And if you do f of negative x, you simplify it, you get exactly the same function as you started with, except with the minus sign out front, and that tells you it's odd. Now, if neither one of these cases happen, that means it's not even and it's not odd. So it could be neither when you classify these. So there'll be problems like this where in the homework, we'll just ask you to determine whether it's even, odd, or neither. So we want to go ahead and classify that. And so you want to make sure you show your work with these kind of problems. So again, the work that you're showing is finding out what f of negative x is. So I want to start with f of negative x. And that just means that you put a negative x in for all the x's. So it's going to look like that. Okay, so it's we have negative x to the fourth power plus 7. And we want to simplify this. Now remember that anytime we have a negative that's raised to an even power, the negative sign disappears. So f of negative x equals x to the fourth plus 7. Well, x to the fourth plus 7 is our original function. So basically that says that f of negative x equals f of x, which means that we're going to classify this as even. Okay, so as long as you get this as a result, if you get the same thing you started with, and we did, f of negative x equals the original function, then we know it's going to be even. So that's what we have here. Okay, so we simplified it, negative went away because it was raised to an even power. All right, so let's try another one here with that. We'll try this next one. Again, we want to find f of negative x, and this is the same test you're going to do every single time. You always want to make sure you find what f of negative x is. So we're always going to do this first. So negative x goes in there for each of those, just like this. Then we're going to simplify this. Now this time we have a negative that's raised to an odd power. Anytime you have a negative raised to an odd power, the negative sign remains there. So it's going to be, in this case, the negative actually comes out. We're going to get negative 6x to the fifth. This negative is also going to come out. This is to the third power, make that clear here. That negative will come outside. And since there's already a negative out front, that's going to turn that into a plus. So we get plus x to the third. Okay, now this is not the same as the original one. So we know for sure it's not going to be even. But because one of the definitions has a negative sign out front, we want to go ahead and factor out a negative on this. So if it's not even, then this is what you should do. You should factor out a negative if it's not even. Okay, so let's do that. Really what you're doing is you're factoring out a negative 1. Okay, so if I take that out there, I get 6x to the fifth. This is a plus. If I take out a minus, that's a minus x to the third. The part in parentheses is the same as the original function. So now we can say that f of negative x is equal to negative f of x. And that is the definition for odd. Okay, So that is the answer on that one. So if you don't get the same thing that you started with, then I recommend factoring out a negative to see if you still get the same function that appears after you factor out a negative. Because sometimes you do. If you factor out a negative, then we get the same original one. That's why we have a negative f of x, because the part in parentheses, that is our original f of x. And so that's the result we got. F of negative x equals negative f of x. So again, we say that is odd. Next example, we have x squared plus x. So let's put in f of negative x. We'll put in a negative x for each of the x's. So we'll put in negative x in for both of those. And then you want to simplify it. F of negative x equals, okay, now this one, a negative raised to an even power means that the negative goes away. And I have a minus x here. That's not the same as the original one. Now I could go ahead and try to factor out a negative since I didn't see it matching the original one. However, this time, if I factor out a negative, then I still don't get the same thing I started with. I get negative x squared plus x. That's not the same as the original one. So this kind of problem is an example of neither. Okay, so this one is, it's not even and it's not odd. Okay, it's neither, because we didn't get the same thing we started with, and we didn't get the same thing we started with a negative sign in front of it. So because we didn't get that, then it's considered to be neither. Okay, so that one, part C, is nothing. It's neither. Now, there's a couple more I want to try that look different. So far, we've done ones that are polynomials here, but let's go and start doing a couple different ones. You want to do some fraction ones next. So let's take a look at these two problems here. So there was, even though it looks different, you're still going to do the same thing. You want to still put in a negative x for all the x's. So I want to find f of negative x, which means that you're going to put in a negative x for all the x's. So on top, we have absolute values there. That's what these lines mean, absolute values. Okay, then we have negative x in the bottom. Now on top, we can do a little bit of simplifying on that. The negative actually comes out and we get absolute value of negative 2x over negative x. And then also what we can do is we can take the absolute value of negative 2, and the absolute value of negative 2 is 2. So actually, let me go ahead and write out the steps for you. So when you look back at this later, you can see kind of what I did. So I split this up as absolute value of negative 2 and the absolute value of x. You are able to do that. With that, that's kind of what we're doing there. We're separating it. And so that way you get that's positive 2 absolute value of x over negative x. And actually the negative we're allowed to put on the outside like that. Now I can also put the 2 back inside the absolute value. Since I've taken the absolute value of it already, I could actually move that back in. And the reason why I'm doing that is to make it look like the original one. I have a negative out front, and I have absolute value of 2x over x. Now this part is exactly the same as the original one, except we have a minus sign out front. So I have f of negative x is equal to negative f of x. So this is another one that's considered to be odd. Okay, that's the answer on that. So I did a bunch of different steps. Now you don't have to show all these steps for something like that. You actually could have, in this step, you could have gone from here directly to this one, because you could just could have taken the absolute value right away and gotten down to this step here. But I wanted to show you just, what the math looks like, what you're really doing when you separate all that. So that's why I show these extra steps, but it's not necessary to show these. You could actually just go right from here to this one. And so that's considered to be odd. We're going to do another one of these. We have another fraction one. So we'll do that. There's one like that in the homework. So we'll do the fraction one. So on top, we've got negative x. That's to the third power. And at the bottom, I have negative x squared minus 9. Okay, so I have a negative n for the top and a negative n for the bottom. Let's simplify this further. Okay, I have a negative raised to an odd power. That means a negative comes out. So I have negative x cubed. A negative raised to an even power means I get x squared, just like this. All right, so now the part that I'm left with, this negative on top, I'm allowed to pull it out front. So f of negative x is equal to negative x cubed over x squared minus 9. So I'm putting the negative out front of everything, and you're allowed to do that. If you have a negative, you can either put a negative on top, on the bottom, or pull it out in front. So I pulled it out front here. This part, x cubed over x squared minus 9, that part is the same as the original one. So I actually have another case where I have f of negative x is equal to negative f of x. By definition, again, just like the previous example, that's odd. Okay, so we have that. That's considered odd because we get the same thing as we started with, except we have a minus sign out front. If we got exactly the same thing we started with, then it'd be considered to be even in that case. Okay, so some other things that are in this section is average rate of change. Okay, so average rate of change is, it's kind of like a slope again, because it's actually using the slope formula, as you can see here. But this is the formula that you would use for that. It's really the same thing as using the slope formula, but now we're using special function notation instead on this. So that's the next kind of problems that we'll take a look at, and those are also the ones that were in the homework. So average rate of change. So basically what you're doing is you're finding like an average slope on something. So if, for instance, if you got a curved line like this, and you're putting 2 points on there, and you have that go through like that, you're finding what the average slope is between those. Rate of change is another word for slope. So essentially that's what you're doing on these kind of problems. All right, so we're going to plug this information into here. So I want to use this. It gives you x1 and x2. So let's first start off by putting that into the formula. F of x2, f of 2 minus f of x1, f of 0, all over x2 minus x1, 2 minus 0. So that's what we have so far. Now, we want to figure out what f of 2 and f of 0 are. So let's do that off to the side over here. F of 2, we want to find. To find f of 2, we're going to go back to the original function, and we're going to put a 2 in there for x. So negative 3 times 2 squared plus 3. F of 2 is equal to negative 3 times 4 plus 3. So f of 2, make that more clear, f of 2 is equal to negative 12 plus 3. That would be negative 9. So now I know what f of 2 is. Next, we want to find f of 0. F of 0 is negative 3 times 0 squared plus 3. That first part's just going to give you a 0. So f of 0 is equal to 3. Now that I have the values that I did off to the side, I can plug those into the average rate of change formula. So that's what I'll do next right here. F of 2 is negative 9. We have minus f of 0 is 3. On the bottom, 2 minus 0 is 2. Negative 12 over 2 is negative 6. And that would actually be the answer to that one. That's the average rate of change. That would be the, if I take this line, this graph here, and I pick 2 points, x1 is 0 and x2 is 2, that gives me what an average slope would be between those 2 points. So again, that's called average rate of change, is what we're doing on that. All right, let's do the next one. We have a cube. We're going to find the average rate of change from 1 to 3. So they always have to tell you what these are. The smaller number is always x1. The larger number is always x3. So they have to give you those, and you'll basically follow the same formula again. So I want to do f of x2. So this is f of 3 minus f of 1 all over 3 minus 1. That's the setup. It's f of x2 minus f of x1 over x2 minus x1. So it's always the same setup that you do for each. Now I just have to find out what f of 3 and f of 1 are. So let's do f of 3. You put that into the original one. We're going to put a 3 in there for all the x's. Like this. So that's 27 minus 3 plus 2. So that's going to give you 27 minus 3 is 24 plus 2 is 26. So 26 we get for f of 3. Now we want to find f of 1. So that's separate. So now we put a 1 in there for all the x's. 1 cubed minus 1 plus 2. And the 1's cancel out there. So 1 minus 1 is 0. So we just end up with 2. So we found f of 3 is 26 and f of 1 is 2. We can now plug those into this formula, average rate of change formula. F of 3 is 26. F of 1 we found down here is 2. 3 minus 1 is 2. We have 26 minus 2 is 24. 24 over 2 is 12. And 12 is going to be our answer. There's no special units you have to put on here, by the way. You're just going to put the number in only, and that's going to be it. So no special notation or numbers you need for average rate of change. Let's do one more of these. Okay, we want to find the average rate of change from f of x is square root of x from x1 is 9 to x2 is 16. So now let's try this again. F of x2, actually, let's go ahead and plug those in. X2 is 16, so we're going to do f of 16 minus f of 9 all over 16 minus 9. We're going to do this off to the side. F of 16 is the square root of 16, which equals 4. F of 9 equals square root of 9, which equals 3. So we found f of 16 is equal to 4 and f of 9 is equal to 3. Then you can just plug those directly into here. 4 minus 3 over 7. And then you get 1/7. So you're not always going to get a whole number on these. It's possible for you to get a fraction like we had here. And that's going to be your answer for the average rate of change. Okay, so next we're going to go on to the next section here. Unless anybody, first of all, before we go on to the next section, does anybody out there have a question on what we've done so far? We did average rate of change, and we also did even, odd, and neither. Does anybody have any questions on that first before we go on to the next section? Questions on that? All right, doesn't sound like it. If you think it's something, you can ask it at the end here. We're going to go on to the 2.4 section. Now, this 2.4 section has a bunch of graphs for you in the beginning. And this is all on the front page of your notes. So you should have all these special graphs that are on there. I'm going to leave this on the screen, and just give me 1 second. I have to get something from the other room, so that way I'm ready here. Hold on 1 second. And sadly, my dog doesn't enjoy these lectures, so unfortunately, she's doing something else at the moment. So sorry about that. I had to take care of that. All right, so let's go ahead and come back here to library of functions, piecewise functions here. So what this is a list of library of functions that we have here. So we have different functions. We have these square root function, absolute value function, identity function. And I listed the domain and range for each, but really all you have to be concerned about is the actual points that you have on each of these. And even though you can see them on the graph, I'm going to go ahead and label some key points for you because we're going to use these later in order to graph. So first one we have here is let's see, get rid of this dot here. Okay, so we have 1, 1, and we have 4, 2. Okay, so I have 1, 1, and I have 4, 2. These are twos, and also, of course, we have 0, 0 here as well. As all of them are going to have, 0, 0. The next one here is 0, 0, and then also we have. It doesn't matter which one of these you use, but I'm going to use this one here as 1, 1, and this one here is -1, 1. So what I'm creating here is a list of points that the base graph have, and then I'm going to, so this identity function we're actually not going to look at because it's a line. And so because it's a line, we're not really going to be doing too much with the identity function. There's not really any key points we have to worry about here because it's just going to be the same thing as a slope. Close the door here. Okay, so next thing we're going to do is go on to the next functions down below here. So we got the quadratic function. We have 0, 0. This is going to be at 1, 1. And then this is going to be at 2, 4. Then we've got this one is at -2, 4, 1, 1, and 0, 0. So we're going to come back to these key points. So I want to go ahead and give those to you now because we are going to be referring back to them. What this whole section is involving is in the past, we've graphed functions like this by making a table. We made an XY table and spent all the time finding all the coordinates, the -2 and a 1, 0, 1, and 2. For instance, we pick X values, plug them into a table, we get the Y values. But what we're trying to move on to graphs that we can quickly sketch without making tables. That's what this whole thing is all about. So if we know what the base graph is on that, then there's certain things that we're going to learn called transformations, and that involves shifting the graph left and right or up and down or flipping it to where we can take the base graph, such as this one, where we have all these key points. We're just going to move this left, right, up or down or flip. So that's the reason why we want to know what the original key points are, because these are the ones we're going to start with when we actually talk about moving the graph and shifting them around. So this one has 1, 1. This is at, again, of course, all these are centered at 0, 0. And we have -1, -1. Now, way up here, this is not the actual place where this point is, but I'm just going to go ahead and put that in here. 2, 8. And down here, you'll have -2, -8. Okay, so I have these 2 points here, -2, -8, and 2, 8 that I have for that. Okay, so these are the key points that would be on the cubes. This is -1, -1 here, just to make that more clear. And then the cube root function, we have 1, 1, 0, 0, -1, -1, -1. And then way out here again, I'm going to have 8, 2. And all the way out here, I'll have -8, -2. Okay, so these are all points specifically that this graph goes through. And this is called the cubic functions. Let's move this down so we can see what these are. We've got the quadratic. Anything that it's raised to the power of 2 is quadratic. Anything that's raised to a power of 3 is a cube. It's a standard cube function we have there. And we have a cube root that's there too. So this is the cube root of x. So we have all the domain range, increasing, decreasing, but not really going to be talking about that too much in this section. These are just some characteristics that we have of all that. So that's the first thing we want to make sure we know, is make sure we understand what these shapes are from the formula. So if I see x squared, I know it's a U shape. If I know it's a cube, we've got a kind of bend in the graph there. And then the cube root is like the cube on its side and so forth. We want to make sure we know what all those look like, because part of the problems that you'll see in this section, it's going to ask you to identify some of these graphs. Okay, so there'll be the first type of question in this section is a matching kind of question. So it's going to have you match the graphs to the name that you have. That's the first couple graphs you'll see on there. Yeah, let's go up and see. I'll give you these 3 graphs first here. Okay, so here we'll scroll up there in case you need to see the other ones up above. Don't worry about the identity function. The identity function, they'll have you identify it in there for this, but so for identification purposes, yes, you do have to know basically what it is, but it's just basically a line. It's just a line, specifically the line y equal x. It can't be a horizontal line. It's got to specifically be this line right here. That's the identity function that looks specifically like that. It's just y equals x. It's the same thing going up like this. So the first type of questions you'll see in my open math are just some matching questions. You're going to match the graph with its name down below. That's the first kind of problems that you're going to do there. All right, so let's scroll down and let's talk about what some piecewise functions are. So what this is, it's going to be actually using pieces of these that we see here in order to do piecewise functions. So this section, when we get into 2.5, 2.5 is talking about the transformations. That's what I talked about earlier, where you'll take a graph and you'll move it left, right, up, or down, or flip it. So we're not going to get to that in this section. We're going to get to it in section 2.5. I just wanted to let you know ahead of time that that's why I'm providing these list of points for you, because we're going to refer back to these when we get into section 2.5. But right now, because we're in piecewise functions, let's define what a piecewise function is here. So piecewise functions are functions that are made up of different pieces. Now, you could have as many pieces here as you want. Now, what's characteristic about that is if you look at this example here, each equation actually has special conditions that we have on it. So this is saying that the equation x plus 2, that's only defined if x values are less than -3. For instance, that means that I can only use this function if my x values are less than -3. But the bottom one, I'm only going to use that one if my x values are larger than or equal to -3. We can use this idea in order to evaluate each of these here. What you're going to do is you're going to look at the number inside the parentheses, and you're going to see which of these two conditions that number would make true. If I plug that number in for the x in the condition, I need to get a true statement. And if I get a true statement, that means that's how I know which equation to use. All right, so I have -4. I know that -4 is less than -3. That's true. So that -4 would make the first equation correct, which means I need to use the top equation. So I want to use f of x equals x plus 2. F of -4 is equal to -4 plus 2. And this is -4, not -x. Sorry about that. -4 is what I meant to write. F of -4 is equal to -4 plus 2. So f of -4 is equal to -2. That's going to be the answer on that question. So again, we chose the top equation because if I put -4 in here for x, that makes that condition true. It does not make the bottom condition true. -4 is not greater than -3. Okay, -4 is less than -3. Now, what you might be thinking is, well, is it possible that I have to use both equations and I'll get two answers? And the answer to that question is actually going to be no, because notice what we have here. It says piecewise functions. Now, recall the definition for a function means that for every input, there can only be one output. So if I put a number into here and I get two different outputs, that means it's not a function. Okay, so you're never going to see that here. When you're evaluating these, you should only get one answer. So let's now take a look at f of -3. -3 is not included on the first one, but -3 is included on the second one. -3 is greater than or equal to, it's equal to -3. So I'm going to use the second equation. So I want to use f of x is equal to x minus 2. And I want to find f of -3, which means I want to do -3 minus 2. And that's going to give you -5. So -5 would be the answer for part B. Part C, f of -3/2. Now, if you're not sure what this is, okay, this is the same thing as -1.5. We want to check to see which one of these conditions is true. If I put -1.5 is not less than -3, but -1.5, that would be larger than -3 because -1.5 is actually closer to 0 than -3 is. So that means I got to use the bottom equation again. So I'm going to do f of x equals x minus 2. F of x is equal to, or f of, let me put the number in there, f of -3/2 is equal to -3/2 minus 2. If you get common denominators, you have -3/2 minus 4/2. That's going to give you -7/2. And so -7/2 would be the answer on that one. So that's the first type of question that you're going to see on there, is you're going to see some evaluate type questions, first of all. Next, they want you to graph this. Now, for graphing purposes, what I recommend is you can use tables on this. So what we're going to do is we're going to separate this and make a table for each of these two functions. And I'm going to pick some values on there, and the values that I pick have to match the conditional statements that I have here. For instance, if I wanted to test x plus 2, then when I make my table, I want to make sure my values are less than -3. Now, with these piecewise functions, no matter if that number on the end is included or not, you want to make sure you have this number on your table. So for instance, let's make a table on this. So I'm going to do x, and I have y equals x plus 2. I'm going to make a table on that. The first number I want to pick here is -3. Now, I'm picking -3 purposely because when we do these type of graphs, you're going to see that the graph is either going to start or stop at -3. Now, of course, we know that -3 is actually not included. However, so what's going to happen is on the graph, that's going to show up as an open circle. Okay, so let's put that in there. -3 plus 2 is equal to -1, which means that at my xy here, I'm going to have -3 and -1. And this right here, I'm just going to go ahead and put a little open circle. That's an open circle symbol, just to remind me that when I graph it, or plot that point, it's going to show up as an open circle. And then you can pick any other number besides that. So because this is a line, you only need 2 points to determine a line. So I just need to pick another number that's less than -2. So maybe I might want to try either -4, or I can use -4 since I already did that previously. So -4, we did that earlier, and we got -2, which means that the point -4, -2 is going to be plotted. Let me go down to the graph and show you what that's going to look like. So I have -4 and -2 there. And as you can see here, I made these tables up for me earlier that have more values on it, but you don't have to put all 3 of those values on it. 2 values are enough. So here we've got -3, -1 is supposed to be an open circle. -3, -1 is an open circle. Now the rest of them that you have are going to be closed circles. Okay, it's only that specifically -3 is open circle because we see that's not included here. Next one is -4, -2. -4, -2 goes right here. What's going to happen is we have a line that's going to connect these, so it keeps on going down like that. And so there's no more graph that appears after the open circle. Now, the reason why you don't see a graph appear anywhere else to the right of -3 is because of the conditional statement. Conditional statement says that x has to be less than -3 only. So this is the line right here that we have for the x value of -3. The graph does not cross over and does not go to the right because the x values have to be less than -3. So that's why you only see this part of the graph appear. So that's the first part of the graph. Now the next one is we want to look at the bottom one. So let's make a table for the bottom one, y equals x minus 2. And we'll do the same thing here with x and a y like that. And so we're going to do -3. Now this time, -3 I'm using because again, it appears in the conditional statement, but I have a greater than or equal to symbol here. Greater than or equal to means that this point is actually included. So when I graph this one, that point is going to be a closed circle there because I have it included. It has the equal sign there. Now we already done this one earlier. -3 minus 2 is equal to -5. So we get the point -3 and -5. Then we'll try one more, any other point. It can be any point that's greater than -3. 0 is an easy one to try, so let's do 0. So I have 0 minus 2, and that's equal to -2. So 0, -2 I get for that one. So now I want to plot these 2 points here. I want to plot -3, -5, that'll be a closed circle. And I have 0, -2, which will be a closed circle as well. So I have, let's do 0, -2, that's a closed circle right there. And I have -3 and -5, which is going to be right there. Okay, -3, -5. And so this one, the graph is going to look like this here. The graph starts at the x value -3, but you're only going to see it going this way. You're not going to see the line going the other direction. You don't see it going the other direction because this is only defined for values that are greater than or equal to -3. So that's why the graph only appears on the right-hand side of -3. So it goes this way. Okay, so this is basically these tables here. I kind of did, I wrote these originally, but I did the same tables up here. You only need 2 points to draw on each of these because these are linear functions. And as you see here, they are linear, but they're 2 different pieces. We have this piece here, and you have this piece here, and that's what we have for piecewise functions. Okay, so now next, we'll try another one. So all these kind of problems we'll start out with by doing, there'll be evaluate function first, and then there'll be ones where you're going to draw it. So there's a couple problems that are in the homework that have you do something similar to this, where now in the homework, there's like a multiple choice thing that you're going to choose. So we're going to do that. And then I'm also going to show one of these at the end from the homework, because there's one We have to kind of draw something that's a little bit different. So I'll show you that probably tomorrow is when we'll get to that one. But anyway, we'll continue on with what we have here. Okay, so let's go ahead and do this one. We have two functions again. We have -1/2 x squared if x is less than 1. We have 2x plus 1 if x is greater than or equal to 1. So what I'm going to do this time is I'm going to go ahead and let you try these right here. So just why don't you go ahead and try and work on these three. I'll give you some time to do that. And then we'll come back and we'll do them together and check. So you don't have to worry about, don't graph it just yet. Why don't you just go ahead and do this. And so I'll give you some time to go ahead and work these out. I'll give you a minute or two, and then I'll come back and I'll work those out for you. So why don't you try these problems A, B, and C, and we'll go ahead and come back to it. So just a reminder, what you do is you look at the number that's inside the parentheses and you compare it to the conditional statements here. That's going to tell you which one of those equations you're going to use. So for instance, this f of -1, -1 is less than 1. So use the first equation for part A. So again, you want to go ahead and do the same thing. So take a minute or two and go ahead and answer these. I'll be back in a minute, and we'll go through all these all together, and then we'll take a look at the graphs. I'll be back in 1 minute here. All right, so we'll go ahead and let's do the first one here. So f of -1. We mentioned that -1, you're going to put that into only the first equation because -1 is less than 1. So if you did that, then this should be equal to -1/2 times -1 squared. So f of -1, give me that mark here. F of -1 is equal to, so this negative squared becomes a 1. And so you should have gotten for the first one, -1/2 for that one there. For the 1, that one, you should have used the bottom equation because 1 is equal to 1. So we want to use that. So for the bottom one, we're going to do 2 times 1 plus 1, or f of 1 is equal to 3. Okay, so that would be your answer for that one. Now, if this one is throwing you for a loop, if you're not sure what square root of 9/10 is, you can always do that on your calculator. Okay, so if you do, so the reason why we need to do that is because we have to figure out whether is this larger than a 1 or is that less than a 1, because that's going to determine which one of these that you use. So if you want to use a calculator on that, you're basically going to take the square root of 0.9, because that's what 9/10 is going to be there. And if you do that, this decimal is about 0.94. Okay, so 0.94 is less than a 1. So we have to use the first equation. So I'm going to do, so basically this is going to equal -1/2. I'm going to put the square root of 9/10 in here, and that's being squared. So I'm putting that into the first one because 0.94, the square root is less than a 1. That's why I'm doing that. Then I can simplify this. So the square gets rid of the radical, and I get 9/10 left over. If I multiply across the top, across the bottom, I get -9/20, and that's going to be the answer on that one. So sometimes you might have to do, if you're not sure what number it is they want you to plug in, then you might have to do that in a calculator to figure that out, like I did here. So 0.94, then we put that in there, and then we get our answer. All right, so now we're done with that. Let's jump down to the graphs. So I went ahead and these tables I already have created. if it's not a linear function, like if you have a square, a cube, or something like that, I recommend for sure you want to use at least 3 points because you don't want to miss the shape of the graph. If you use 2 points, you might get the wrong graph. So I'll show you that a little bit later what I mean by that. If it's a linear one like this, only 2 points are necessary, but I'll show 3 points anyway on that. So I'm going to fill all this out, and then we're going to plot all this on there. So here's the original functions I had before. I'm going to graph each of these separately. So I picked these values. Now the reason why I picked these specifically is remember that the first equation was only valid for x values that are less than 1. Okay, so less than 1 means -1 I can use, 0. Notice that I am using a 1, even though that point is not included originally. It said less than 1. I still want to use that because that's going to end up being an open circle, and that's going to determine where my graph ends. So that's why I want to do that. So -1, I have negative squared. This is going to be -1/2. So I have -1 and -1/2 right there. And this, I don't know why I wrote this is not needed here. Okay, so it's not needed. Okay, so I have -1 and -1/2. Let's do 0. So I have 0 squared. Is that whole thing is going to just give you a 0. So 0, 0. It goes through, and then I have a 1. So 1 squared equals -1/2. So I have 1 and -1/2. Let's plot these. So we mentioned that the most important one to note is that the 1 and -1/2, that one needs to specifically be an open circle, because if I look at the original conditional statements, I have a less than symbol, but I don't have a less than or equal. So because it's less than only, that's why I'm using an open circle. That point's not included there if I have a less than. Now the rest of them, 0, 0, and then also -1, -1/2 like that, that's okay to use there. Because it's a square, we end up having a kind of upside down parabola thing. It's going to kind of look something like this. All right, so a square always has a U shape to it. Now the reason why it's important to plot 3 points is, let's suppose we didn't do the first one. We didn't do -1 and -1/2. Well, if we didn't do that, we only had these 2 points. You might accidentally draw this as a line going out like that. So you need the third point there to determine the overall shape. So anytime it's not a linear one, you definitely want to do at least 3 points there to determine the curvature of the graph that you have. So you want to make sure that's done correctly there. So that's why we did that. Okay, now next we want to do the linear one. So I picked 1, 2, and 3 here because this one, if you remember, that one is only defined here where x is greater than or equal to 1. So 1 is definitely included there. And then I have 2 other points that are larger than 1. It doesn't matter which ones you pick, as long as it fits in the graph grid that you have. That's the most important thing. So let's do 2 times 1 plus 1 gives you 3. So 1, 3 is the 1 point you find there. 2 times 2 plus 1 is 5. So 2, 5. And we have 2 times 3 plus 1 is equal to 7. And so we get 3, 7 for that one. So let's plot these. 1, 3, that's going to be a closed circle for sure, because the 1 was included. I had greater than or equal to 1 in the original piecewise functions. That means the 1 is definitely included. So I have 1, 3, then I have 2, 5 is there, 3, 7. Okay, so 3, 7 is up here. So 3, 1, 2, 3, 4, 5. Actually, that's something's not right here on that one. Let's see, that is 3, 7. That's why. Okay, so 3, 7 is up here. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 is up here on that. So get rid of those here. All right, so with that, I have these 2 points. Again, you don't really need to do this third point if you don't want to. on there. You can if you want. Oh, I see what I did wrong. That was supposed to be up here. Yeah, it's 1, 3, and then 2, 5, and then 3, 7. Yeah, up here. It should all form a straight line like that. Again, you really only need the first 2 points only to determine that, but that's going to be your answer. So notice that the first one is only using values that are less than 1. So that's why you only see the graph going to the left like that. The other one is greater than 1, and that's going to go to the, it's only going to go to the right, or to the right of the value of x equals 1, because that's only defined for values that are greater than 1. So we got this piece and we have that piece. So 2 different pieces we have for that. However many equations that you have, that's how many pieces of the graph that you're going to have here. I do want to do one more of these. So I'm going to do one more that has the 3 pieces on this. So we have these 3 pieces, each of these here, and we want to evaluate these. So we're going to go ahead and answer those 3 here. Now this is a little bit different. We haven't seen one like this before. So this says that x is equal to 0 if x is less than or equal to -3. So that means no matter what, as long as you have an x value that's less than 3, automatically your y value is always going to be 0. That's what that first equation means. Now the second one, it's only defined between the x values of -3 and 0. And the third one is x is greater than or equal to 0. So now we have 3 different pieces. To evaluate this, we're still going to do the same thing we did before. We're going to look at the values of the parentheses, and we're going to compare it to see which one it belongs to. The 0 inside would only make the bottom equation correct, because 0 is greater than or equal to 0. So this tells me that I need to use the bottom equation. So I want to use f of x equals x squared minus 1. F of 0 is 0 squared minus 1. F of 0 is equal to -1. Okay, so that's the answer for part A. Part B, we want to do f of -1. All right, so -1 is going to fit. It doesn't work with the first one because -1 is not less than -3. However, that will work with the second equation because -1 is both larger than -3, but at the same time, it's also less than 0. So you want to use this. So I want to use f of x equals -x. Well, if I want to find f of -1, that means I have a negative here, and I'm putting a -1 in for x, so I get a double negative that happens on that. So f of -1 is going to equal +1, and that's your answer for part B. Part C, okay. Yes, we could put this into a calculator to figure out what square root of 10 over 2 actually is, but let's think about what type of number this is going to be. Square root of 10 is going to be some positive number, and you're dividing it by a positive number, which means you're going to get a positive number as a result here. Well, if you look at all this here, the only equation that works with positive numbers is going to be x squared minus 1. So I want to use that one. Now, again, if you're not sure about that and you didn't think about that aspect of it, you can always find the decimal value, which if you do the decimal value, it's 1.58. Okay, so this is 1.58 if you're not sure about it, but because it's 1.58, that would still only work with the bottom equation because that number is greater than 0. So I want to put this, I want to do f of x is equal to x squared minus 1. F of the square root of 10 over 2 is equal to, I'm going to put this in square root of 10 over 2, and then square that minus 1. So let's continue with that. We're going to get square root of 10 over 2 is equal to, okay, let's go get rid of the radicals. So I end up with 10 fourths minus 1. And so if I put that in the calculator and reduce the fraction, so if I reduce it, it's 5 halves minus 2/2 is, I'm going to get 3/2 from this. Okay, so 10/4 minus 1. Minus 1 is going to be 1.5 or 3/2. Okay. Now here's the last one, f of negative square root of 11. Now this is probably one I do definitely want to find the decimal value of, because we have a couple of different cutoff points for negative numbers, so I want to see what that is. So this is going to be negative 3.3 approximately. So negative 3 or 3.32, but in any case, negative 3.32. Let's take a look at my equations and see which one it works with. So since I have something that is less than negative 3, that means that my y value is going to be automatically 0. So there's actually nothing to plug into this at all. If anytime my x value is less than negative 3, my y value is always going to be 0. So this right here, so basically here's the equation I'm using. I'm using f of x equals 0. That was the first equation. So if I put square root of negative 11 in there, I'm still going to get 0 for the answer. So that's my answer for part D. It's 0. Again, anything that is less than negative 3, automatically the y value is going to be 0. And that's what you get for that one. On to the next part, which is going to be, now we have to graph this one. All right, so graphing this one, I need to look at 3 different tables I'm going to make for this one. Here's the first equation. I have f of x equals 0 or y equals 0 in this case. So this one's actually really easy to do, because every time I put an x value in there, I'm just going to get 0 for all of these right here. So we get negative 5, 0, negative 4, 0, and negative 3, 0. Now these, you'll have to come up with these tables on your own. Okay, so the ones that are in the homework don't have tables provided for you. They just have the graphs there given as a multiple choice. So you're just going to choose all that on that one. So the thing you have to remember on this is that if we go back up to the original conditional statement, the original one says that the negative 3 is not included. So at negative 3, I need to put an open circle there. Okay, so at negative 3 comma 0, negative 3 comma 0 is right here. I want to put an open circle on that. Then I have negative 4 comma 0 and negative 5 comma 0. Those are the other points that I have. And so then I'm just going to connect these with a line. And so these are all going to go basically that way to the right, or I'm sorry, to the left. Okay, so that goes to the left. So that's the only part of the graph you're going to see, because it's only 0 if you're less than negative 3, but negative 3 is not included. So that's why we have an open circle there at negative 3. So it's going to be open circle at negative 3. Everything goes to the left in this case. Okay, next one. I have the middle equation. I have this. Now this was a conditional statement that was given originally on that one. On this, I had y equals negative x only if I'm between negative 3 and 0. That was the conditional statement we had in the original problem. So notice the values that I picked here are numbers that are between, I use the n, each of the n's, so I use negative 3 and I use 0. And then I pick 1 in the middle. Okay, so let's plot these. I have negative times negative 3, which is going to give you positive 3. So I have negative 3, 3. I have negative times negative 1, which is going to be positive 1. Negative 1, 1. I have negative 0, which is just 0. So I get 0, 0. Now the 0 is not included here, so I'm going to go ahead and put a open circle there at that point. And then all the other ones are going to be closed circles here. Negative 3, 3, that one is a closed circle, because notice that negative 3 is included. I got an equal sign underneath. And so for sure, negative 3, 3 should be a closed circle, but then 0, 0 will be an open circle. Let's draw that line down like that. Okay. Then I got one more piece I have to do. One more piece is going to be this one here, the y squared minus 1. Again, for squares or cubes, you definitely want to pick at least 3 points for that. This one was given as x is greater than or equal to 0 was a conditional statement here. So notice that all the numbers I picked start with 0 and they go higher than that. So again, these you'll have to pick on your own, but all you're doing is you're picking values that match this conditional statement. So I want to start with always want to pick the one that's part of the condition, whatever number is attached to your conditional statement. You definitely want to start with that one and then pick 2 other points that match the conditional statement. So I want to do the 0, and then I'm going to pick 2 other numbers that are larger than 0. So that would be 1 and 2 would be easy ones to try there. So now I'll plug 0 into here. I get 0 squared minus 1. I get -1 there, so I get 0 and -1. Then I have a 1 in here. 1 squared minus 1 is 0. So I get 1 comma 0. And then I have 2 squared minus 1 is going to be a 3. So I get 2, 3 for that one. So filling out that table. Okay. So I get 0, -1 here is that, and that has to be a closed circle, which it is right there. And then 1, 0 is closed, and then 2, 3 is also closed. So I get a curve that goes like that. And so it keeps going up there for kind of forever there with that. So that would be my finished graph. Again, this is only defined for values that are greater than 0. So it means we're on the right-hand side of the y-axis. That's the values that are greater than 0 that I have. So that would be your finished graph that you would have for that. All right. Now, one more question that we're going to end with today. And that's one where there's one like this in the homework where you want to actually write the piecewise functions for the graph that's provided. So I need to actually come up with the equations for the piecewise function based off of this graph here. So I want to do that. That's one of the homework questions that it asked for. All right, so what I'm going to do here is first I have to figure out what the equations of these lines are. And once I have that, I can find out what the conditional statements would be. So ultimately what I'm trying to find out is I'm trying to find f of x. Let's see, f of x is equal to, and then I have one of these brackets, and then I'm going to put the statements in here. So I'm actually going to write in what the functions are. Now, one thing I can do, actually, I can come up with the conditional statements first. Let's do that first here. The conditional statements. So I have if, okay. So this one, notice that there is an open circle on -1. And the graph is only to the left of the -1. So what that would translate into is x is less than 1. So this is I still have to come up with the equation, but I know the conditional statement on that is going to be x is less than 1. For this one down below here, I'm starting with 1, and it's a closed circle, and it continues to the right. So that's values that are greater than. So I would put greater than or equal to 1. So now I have part of this complete. I have the conditional statements done. All I did was I just looked at the picture and looked at whether it was an open circle or a closed circle, and that told me what that was going to be. So now I have this complete. All right. So next, I have to figure out what each of these equations are. Now, this bottom one is easier because I have a horizontal line. Remember, if you have a horizontal line, it's just going to be y equals wherever the line crosses the y-axis. We see here that the line crosses the y-axis at -1. So actually, that is going to be the equation. F of x equals -1 or y equals -1. That's all you're going to put there for the bottom one. Okay, so this is just a flat line. It's slope of 0, but it crosses the y-axis at -1. So I just have -1 only. That's my answer there. Now this one, I have to do a little bit more work to figure out what this is. Now what I'm going to do is I'm actually going to look at the graph itself, and I'm going to find out what the slope is on this. Now the slope is a change in y over change in x. So I'm doing the for the left line that I have here, my m is equal to it's slanting to the right, so I know it's going to have a positive slope, and so m is equal to 3/2. So if I want to go from this point to that point, all I want to do is just pick any 2 points that are on the line. So I picked this one because it goes through exactly that one, and it goes through that. I could have also done this one down below here and that one. Either way, notice I'm going up 3/2, up 3/2. So that means that my slope is going to be 3/2. Now another point that it goes through, I know it goes through the point of -3, 0. Okay, so I have the slope is 3/2 and it goes through -3, 0. So this is having us go back to something we learned earlier, where that's actually something we did last week when we talked about the lines. So we want to use the point slope formula here to figure out what the equation is. So slope we got from the graph. We also see it goes through the point -3, 0. So let's plug this in. This is our x1, y1. So I have y minus 0 equals 3/2. X minus the -3 will be x plus 3. If we simplify this, we get y equals 3/2 x, and then if I multiply 3/2 by 3/1, I get plus 9/2. So that is the equation for this slanted line, and that's the one I'm going to put in here, 3/2 x plus 9/2. So now I've completed this one, and this is the exact equations that will allow me to draw this right here. So it's kind of, you're doing something in reverse on these kind of problems. You're doing the reverse, so you're finding the equations that match up with the particular graph. So there is one question in the homework that does have you do that. Okay, so again, this one is just a flat line. Now, if you want to think about that, you can also think of the fact that the slope is 0. So that would be, if you use y equals mx plus b, that would just be y equals 0x plus -1, because it goes through that's the y-intercept there. Or again, it just simplifies to -1 because it's a horizontal line. So that's how you want to do that. So this would be that would be the 2 equations that would match up with this right here. So at this point, again, I'm gonna go ahead and I'm gonna stop at this point, but I'm gonna open it up for some questions. If anybody has any questions from anything in this section or the last section, please go ahead and feel free and ask. We are completely done with 2.4, which means that tomorrow we will go ahead and start 2.5, and we'll start going into that one. So if anybody has any questions, feel free to ask them. No questions, so then we'll go ahead and we'll end this meeting. Enjoy the rest of your day. See all of you guys tomorrow.